to talk about today. And a lot of this is just going to be definitions and recognizing what type of method we're using. So a lot of this can be your opinion, as long as you could argue it. A lot of the stuff we're going to talk about today, as long as you could defend your answer, it could be different from the person next to you, but still correct. Okay, so two things I'm going to give you a definition for. Population is all members of a set. So entire population is all members of the set. So if I said I wanted to do some information and poll people in this school, the entire population would be everybody in the school. Okay, a sample is going to be part of the population. So if I told you we were going to talk about our population being all students in this school, a sample could be like this class would be a sample. It's not everybody in the school, but it's a group of people that are in the school. All right, now, the reason we have to define these is because most of the time you don't use an entire population to collect data, you use a sample. So this just says you can get good, I can't speak, statistical information about an entire population by studying a sample of that population. So a lot of times it's not feasible to get everybody's opinion on something, so you get a group. Now, this is just a little example. Just as, suppose you want to know what % of all voters in your city favor a tax increase to pay for school improvement. Very few at this point. Okay, it's likely, it would be impossible for me to ask everybody in the city of Fort Wayne what their opinion was on that, but we could get a group of people together. We're going to talk about different ways we could define that group, our sample, to answer that question. Okay, now here's what I did for each one. There's a name, and then it's not connected to this. This is just like a for instance to give you a starting point here. But these are all just different examples that would fall into whatever the definition is I'm trying to give you. So the first one's called a convenience sample. And what you would want to do here to get this sample going, you select members, literally just based on convenience. And I never spell this word right. Sorry, it's literally right above there. Based on convenience. Like what is easy for the person that's collecting the data. So this is perfect. Okay, this says you want to sample a group of high schoolers to represent this school, and it says you just ask 25 people. I know this class is less than 25 people, but 25 people in your fourth period class. That would be a sample. Now let me ask you, is this class like a good representation of all of Homestead High School? So it depends. Usually a convenient sample is kind of like a little bit lazy. So it's usually not the greatest sample because like I don't think I have any freshmen in this class, so we're not representing anybody there. So if you wanted to give an example, like not everybody's going to get all the way to Algebra 2 in their math classes. Not everybody's taking a math class, things like that. So this is convenient for me to ask you guys a question, but it wouldn't necessarily be a great sample of the entire student population. So in general, I would say it just depends. Like I said, you could defend this, but like if we were specifically talking about here, I would say like, for example, why is this bad? I have no freshmen in this class, so we're not representing them at all. Or I could say you would have to be in a math class to be in this sample, and not everybody in the school is in a math class, things like that. Okay, my second type of sampling method, this is called self-selected. So basically here, the members select themselves is kind of how this works. So you're going to select members based on volunteers. So like I said, basically here, the members kind of select themselves. And in this little example, this just says the teacher wonders if all their students like their teaching style. the teacher sends out a link to students asking them to respond to whether they like the teaching style or not, like a little survey. Okay, now I would say this kind of depends. This could be good information, it could be bad, but basically here, I'm only representing only the people who respond. So if I just gave you like a little survey and say, hey, if you guys have some time, could you fill this out? Then I'm only getting data from people who decide to respond to that. Now, if they would force everyone to respond, then it might be better data. But basically, this is a situation where you have a choice whether you would respond to this or not. So you're selecting yourself to participate in the sample, whereas you don't have to participate. So it could be good or bad. It just kind of depends on what kind of response you would get. All right. Now, the third type, this is called a systematic sample. And this is going to be, basically you would take and order your entire population. And then the way it's considered systematic is we would select members of our sample at regular intervals. So you would somehow order the population and then you'd select members at regular intervals. All right, so just my little example here. It says you want to know what % of students here at the school prefer Coke or Pepsi. So you complete a list of all, or you get a list of like everybody at the school from the counselor's office, and they alphabetize them. So that would be me ordering it. And then I go through and pick like every 15th person as an example. You could do like every 5th person. You could do every 10th person. It doesn't have to be a specific number. I just used 15 in my example. But you would somehow organize everybody and then pick every at an interval of some kind. I used 15 here. Do you think this is like a good or bad way to do it? This is usually pretty decent because you're kind of representing more of the population. Here, you're not picking people in specific classes. This would be your entire population, and you're calling or contacting people every 5 people, every 10 people, whatever it is you decide to do. But this is probably going to give you a better set of data. Okay, the last option, this is called a random sample, and it's kind of similar to the systematic, but you would order the population somehow, whether that's maybe by a number would be the most of the time. For this particular case, you'd give like everybody a number, and you literally would select the members at random. So we could maybe use a random number generator or something like that. So literally here, everyone in the population is equally likely to be drawn. All right, so this one gives you a little example. This says I want to know what percentage of voters in the district favor tax to pay for school construction project. Not relevant here at all. Okay, I assign every voter a unique number. So I don't know, if we had 20,000 voters, everybody would get assigned a number. And maybe you do that alphabetically. There's different ways you could do that. And then you use a random number generator to generate 30 unique numbers out of that list. This is generally, if you can do it, this one or the systematic, these are the two best because you're kind of getting more of a random sample of your population, or you're trying to like get more people included. The first two are kind of sketch sometimes because it depends on who responds to it or what you have decided is a convenient way to collect data. All right, so all we're going to do here, excuse me, I'm going to just give you a little definition here about bias, and then we're going to give like a little example. We're going to see if we can figure out which method and whether you think it's biased or not, like whether the data would be good. And again, a lot of these are just your opinion. So sample, vary, and how well they reflect a population. A sample has that first blank is a bias when part of the population is either overrepresented or underrepresented. Okay, so kind of like what I was saying, if I just pulled the people in this class and I don't have any freshmen in here, then I'm underrepresenting those people, right? So that would be a little bit of an example of a bias right then and there. All right, and then just the definition. A bias is a systematic error introduced by the sampling method. So somehow the way I chose to pick people is not quite good, and in some way we might be able to collect data still, but it's maybe going to lean one way or the other based on what that sample is. Okay, so here's a little example. And I probably should have rewritten these on the page. So I'm just going to write these real quick so you guys can see them. All right, so these are the options. You can have convenience. I know I just spelled that wrong. I know I did. Convenience. You can have self-selected. You can have systematic. These are the 4 options. Or you can have random. So the first part of the question, self-select is like you're volunteering or you're responding to something in some way, but like you basically volunteer yourself to participate in the sample. So those are the 4 options. We're going to figure out which method, whether we think in this particular case it's biased or not, and then just kind of defend your answer. So this is what it says. Newspaper wants to find out what % of the city's population favors a property tax increase to raise money for local parks. What is the sampling method used for each situation, and does this have a bias? Okay, here's what this says. Newspaper article on the tax increase invites readers to express their opinion on the newspaper's website. Which one of those 4 categories do you think that would fall into? Kai, what do you think? Self-selected. Yes, good. Okay. This is self-select. Now, in this particular case, do you think, would this be biased or unbiased? Okay, why? Exactly. If this is a newspaper article, this is only people who get the newspaper who will even see this. So you're way, way underrepresenting because there's got to be a lot of people in the community that are not going to get a newspaper. So that would be the bias there. This is not necessarily bad information to collect, but I would definitely argue that it's biased. Okay. Now, so the same scenario, we're trying to figure out if we want to get a property tax for local parks. This says, a reporter interviews people leaving the city's largest park, like to get their opinion. Which one of those, let me pull this back down. So is that convenient, self-selected, systematic, or random? Systematic has to say something like I talk to every 5th person or something like that. This is convenience. You're just going to stand outside the park, and I'm going to spell this correctly. Yes, this is a convenience. Because you're just going to stand outside the park and talk to whoever will talk to you. Okay, if I'm talking about raising money for a local park and I stand outside the park and ask people questions conveniently for me, do you think this is biased or not? Why? Exactly. This is super biased, right? People that go to the park and utilize the park would probably be in favor of improving the park. So I would say you're only asking, yeah, you're only asking park people. I'm just going to write that. All right, you're only asking people at the park. But what I'm saying with that is those people would probably tend to favor improving the parks because they're actually using that. You're super underrepresenting people that don't use the park, and maybe they don't want to put their tax dollars for something they don't want to use. Okay, yes, and Josh Hardy just said this one is systemic. Okay, a survey service calls every 50th listing for a local phone book. I don't even think they make those anymore, but pretend that they do. Do you guys even know what that is?
Yeah.
Okay. I don't think they've made them for like at least 5 or 6 years. It might be longer than that. But this one is systematic. Okay, now, this is an interesting one. Do you guys think this is biased or not? Okay, now, let me argue. How could I argue that this would be biased? What do you think? Right? They're based on, but who's not in the phone book? Yeah, you're like if not everybody has a phone. That's what I was gonna go with. I could argue this is probably of the three, this is probably the best, but I could argue both ways on this. If you told me no, this is good, Miss Grody, I would have give you credit for that. But I'd also have you think, this is only for people who have phones. So if you didn't have a phone, you'd be underrepresented here. But I would take either argument. As long as you can defend your answer, we're good.
Do you know anybody without a phone?
Off the top of my head, I don't. Now, my parents have a landline, but my dad refuses to have a cell phone. So I guess maybe I could say refuse to have a cell phone. Okay. No phone. Okay, so there's people that exist. So maybe they don't want to pay the park tax. I don't know. All right. This one says, this is a separate example, so this has nothing to do with the tax for the parks. Okay, high school with 150 seniors wants to find the percent of seniors who plan to attend college. A list of every senior is obtained and each student is assigned a number from 1 to 150. 40 random unique numbers are generated. The students whose numbers correspond to the numbers generated are asked and their results are recorded. So which type of, this is random. Because it doesn't say like every fifth person or something like that. It just says everybody gets assigned a number and we're going to randomly find these numbers. Okay, this is the only one on here that I would argue is not biased. And this would actually be a really good way to collect information on this one. I don't think you could argue biased here because you're taking the whole population, you're randomly selecting, and 40 out of 150 is actually a significant sample out of that population. So this would give you really good data. So if you say the biased is no, you don't have to give me an explanation for that. Is anybody having a question?